3 normed space and inner product spaces. In this section we are going to deal with normed spaces. Normed space is a vector space with a function called a norm that assigns a real number to each vector in the space. Actually, norm is a generalization of the concept length of a vector. These are the properties of a normed space. First property says that norm of a vector is always non-negative. Second property says that norm of a vector is equal to 0 if and only if the vector is a 0 vector. Third property says that norm alpha x, that is when we multiply a scalar alpha with a vector x, then its norm will be equal to mod alpha into norm x. Fourth property is called triangular inequality, which says that the norm of the sum of two vectors is less than or equal to sum of the norm of two vectors. Let's go through some examples. First, let's consider C square, that is vector space C square over C, where C square means collection of all ordered pair x1, x2 such that x1 and x2 are complex numbers, that is elements of C. So we are going to define a norm on this C square. Let's consider an x is equal to x1, x2 element of C square. Then we are going to define norm x as norm x is equal to square root of mod x1 square plus mod x2 square. Okay, so we need to show that this norm, that is this norm will satisfy all these four properties. So first we need to show that norm x is greater than or equal to 0. So here it is understood that these are positive numbers. So these are always greater than or equal to 0. So the norm x will be greater than or equal to 0. So what will be the second property? Second property is norm x is equal to 0 if and only if x is equal to 0. Let norm x is equal to 0. Norm x is equal to 0 if and only if square root of this is equal to 0. Square root of a number is equal to 0 if and only if that number, that is mod x1 square plus mod x2 square is equal to 0. If and only if these are positive numbers, so sum of these positive numbers is equal to 0 means mod x1 is equal to 0 and mod x2 is equal to 0. x1 and x2 are complex numbers. So the mod is equal to 0 means that x1 and x2 is equal to 0. So x1 is equal to 0 and x2 is equal to 0, which is if and only if x is equal to 0. Okay, so let's move on to let's check the third property. Third property is norm alpha x is equal to mod alpha into norm x. So that's the third property. So first we need what is alpha x. Here x is equal to ordered pair x1, x2. So alpha x is equal to, we need to multiply alpha to each components x1 and x2, that is alpha x1, alpha x2. So what is norm alpha x? It is equal to square root of mod alpha x1 square plus mod alpha x2 square. this mod alpha square is common in both terms, so we can take that outside of the square root, so it will become mod alpha into square root of mod x1 square plus mod x2 square. So this is norm x, so this is equal to mod alpha into norm x. So the third property is also satisfied. So let's check the fourth property. Norm x plus y is less than or equal to norm x plus norm y. Let x is equal to x1 y1, sorry, x1 x2, y is equal to y1 y2. Therefore x plus y will be equal to x1 plus y1 x2 plus y2. Okay. So what is norm x plus y? By the definition of norm, it is equal to square root of mod x1 plus y1 square plus mod x2 plus y2 square. By Minkowski's inequality, that is this inequality, Minkowski's inequality, we can split the square root. Here instead of p we have 2. So by using that inequality, this is less than or equal to square root of mod x1 square plus mod x2 square plus square root of mod y1 square plus mod y2 square. This is norm x plus norm y. So the fourth property is also satisfied. So this is a norm in C square. Similarly, we can define a norm on R square, that is R square over R. Consider the vector space R square over R, where R square means collection of all x1 x2 such that x1 x2 are real numbers. We define norm x is equal to square root of x1 square plus x2 square, which is the usual formula to find the distance of a point x1 x2 from the origin. So in general, we can define norm on Cn and norm on Rn like this. Next example is C of closed interval AB, that is collection of all continuous function on closed interval AB. Here we define norm as norm x is equal to maximum of T element J, where J is this set, is this interval, closed interval AB. So it is norm x is equal to maximum of mod x of T. That is, here we are considering the collection C of closed interval AB means collection of all continuous function on the closed interval AB. That is, for example, consider, suppose this is A and this is B. If I draw a function like this is a continuous function on closed interval AB. So this function x is an element of C. And what is norm x? Norm x is the maximum of mod x of t, that is maximum of this value. Suppose this point is 3, so norm x will be equal to 3. Okay, Let's consider another function. Sorry. Okay. Suppose this value is 10, sorry, minus 10, and this value is 2. So what will, suppose this is a function y, so what will be norm y? Norm y is equal to maximum of mod y of t. Okay, we are taking modulus value, so this norm y will be equal to 10. Okay, hope understood the idea. So let's check, does it satisfy all the conditions of norm. Let's go through the first property, that is we know, let's consider the set first. C of AB is the set, that is set of all continuous function of closed interval AB, and here we are defining norm as norm x is equal to maximum of t element of closed interval AB mod x of t. Okay, so the first property is norm x should be greater than or equal to 0. It is already satisfied since here we considering mod x of t, so it will be always greater than or equal to 0. So norm x will be always greater than or equal to 0. So that properties will satisfy. Now let's check the second property. Second property is norm x is equal to 0. We need to show that x is equal to 0. So norm x is equal to 0 if and only if maximum of mod x of t is equal to 0. Okay, which means that mod x of t, maximum of mod x of t is equal to 0 means mod x of t will be equal to 0 for all t, which means x of t is equal to 0 for all t, which means x is equal to 0. So the second property will also satisfy. Now let's check the third property. Third property is norm alpha into x must be equal to mod alpha into norm x. So what is norm alpha x? Norm alpha x is maximum over t modulus of alpha into x of t. So it is equal to, we can take this alpha, mod alpha outside. So mod alpha into maximum over t mod x of t. So this is our norm x. So this is equal to mod alpha into norm x. So that property will also satisfy easily. Let's check the fourth property, norm x plus y, which is equal to, by using the definition of norm, we can say that it is equal to maximum over t mod x plus y of t, which is equal to maximum over t mod x of t plus y of t, which is less than or equal to maximum over t mod x of t plus maximum over t mod y of t, by using the triangular inequality of real numbers. So this is equal to, we can say that this is less than or equal to norm x into, sorry, plus norm y. Thank you.